wanted to come up with a drone that was sort of science fiction-y, sort of outer space. I really wanted to take advantage of the ARP2600's electronic switch. I wanted to change the waveforms as much as I could throughout the drone. This patch uses the ring modulator, but not to ring modulate. All we're doing is taking the output of oscillator 2 and going straight into the reverb, bypassing the filter section. VCO1 is one of our LFOs. The sawtooth is patched into the VCF. The square wave is patched into electronic switch B. VCO2 is our sound source. The sine wave is patched into the VCF. The pulse width is patched into electronic switch A. Modding the pulse width by the sawtooth of VCO3, which is another LFO. VCO2's frequency is being controlled by the make noise relay. VCO3 is another LFO. Our sawtooth wave is modulating the pulse width of VCO2. Our square wave is modulating the y-axis of the make noise relay. Okay. The heart of this patch really is the VCF. The output is going to go into electronic switch C. Turn up your ring mod a little bit below the second to last line. VCO1's square wave is going to go a little bit above the first line. VCO2's square is going to go a little bit below the second to last line, and the saw is going to go in about the same position. Final patch will be the sawtooth of oscillator 1, which is an LFO. And then we're going to modulate the filter by the output of the sample and hold. ADSR is pretty simple. Let me explain the reason we've taken the output of the ring mod and gone straight into mixer out. Without using the ring mod as a ring mod, that lets us take VCO2, bypass our filter, and go straight into the mixer, which is straight into the reverb. The difference in sound is this. And the make noise relay is really making this patch interesting. The x-axis is being controlled by the internal clock out of the ARP2600. The y-axis is being controlled by LFO number 2, which would be our VCO number 3. Really just make up some pitches and let the machine do the work.